This question is an exam style question, and it covers the basis of everything that was done in arithmetic sequences. But most importantly, again, it relies on the fact that you have to understand how arithmetic sequences work and what formulas to use in order to find all the missing bits. So this question uses k as unknowns, and there's a show that's in one of the parts, so it might seem a bit tricky, but it's actually easy to break down and understand. So you have the first three terms of an arithmetic sequence are such. For part A, show that k equals to 2, which means that if you substitute k, you'll actually end up getting a number, and these three are part of an arithmetic sequence, so they have a similar common difference, and so on. So from the beginning, try to understand what's actually happening. Arithmetic sequence, there's a common difference between them, so I'm adding the same number to get to here. Don't concern yourself with the numbers here. There's a 5 here, there's a 10 here, there's a plus 4, plus 2, minus 2. Don't worry about these. But as long as we know that if I substitute k equals to 2, I'm going to get a number, and something's happening between them. Just a hint that if you're stuck at part A, you can skip it and you can use the fact that they've given you k equals to 2 to solve the other questions. So don't just ignore the complete question if you're stuck at part A. You know k is equal to 2, then you can solve everything else. For part A, it's just to show that k equals to 2. So I'm going to use the two pieces of information that I know. One, that this is the first term, second term, third term. So they're in order. I also know that it's an arithmetic sequence. So the fact is the difference between them is 2. So if I have u1, u2, u3, then they would have the same common difference between them. So if I go and say, well, I'm going to take u2. If I'm going to take u2 minus u1, I'm going to get the common difference. And if I take u3 minus u2, then I'm also going to get the common difference. So I'm going to get the same exact thing. So u2 minus u1 will give me the same exact answer as u3 minus u2. Getting to this, translating your thoughts into this sentence is important, because now, well, I know what u1 is. This is u1, this is u2, and this is u3. So I can substitute them nicely in here. u2 is 5k plus 2. u1 is k plus 4. And I'm subtracting them both. So that's a minus. And then I have u3, which is 10k minus 2. So 10k minus 2. A minus u2, so I'm going to subtract 5k plus 2. Now, because you're subtracting a term, please put brackets in here. Because it's no longer minus 5k, it's minus 5k minus 2. So you are, just put everything in brackets. So u2 minus u1, 10k minus 2 minus 5k plus 2. If it was a plus, we can ignore the brackets, but because they're minus, it's a bit more tricky. So I'm just going to get rid of these. And so what we're going to do right now is simplify the expressions. So I'm going to go, well, this is 5k plus 2, nothing changes. The negative, it's actually, there's a 1 in here that we don't write, so it's like negative 1 times k, negative 1 times plus 4, so it's going to be negative k minus 4 equals to 10k minus 2, and again, the negative spreads out, so 5k minus 2. So now we have an algebraic equation with k as the unknown. So let's collect all the k's together. We have 5k here, we have negative k, we have 10k, and we have negative 5k. So if I collect them all together, and then I'll collect all the numbers on the other side as well. You could do this step by step, or you could do it in one step as I'm doing. So I'm going to have 5k minus k minus 10k, be careful with the signs, and then plus 5k equals to, I'll have negative 2 minus 2, these are the two ones here, and then these two will be again minus 2 and then a plus 4. We're going to simplify these. 5k Minus k is 4k, minus 10 will be a negative 6k, and then negative 6k plus 5k will be just a negative k. Negative 2, negative 2, negative 2, that's negative 6, and then plus 4, that will give me a negative 2. And so I'm going to divide by, to get rid of the negative, you're going to divide by negative 1, and as we know, negative and negative goes away, so we end up with k equals to 2. And so we found the first part. Show that k equals to 2, and you've done it. And we've just used the fact that in arithmetic sequences, the difference is common. So a nice trick to know and possibly to use again. So for the next part, and this is where you're going to see that you actually didn't need part A. So find the values of the first 3 terms of the sequence, which means, well, if I know k equals 2, this is the first term, second term, third term, let me just substitute the numbers in there. So I'm just going to go 2 plus 4, so 6, that's U1. And then 5, 2 plus 2, so that's 10 plus 2, so 12, that's just U2. And then 10 times 2 minus 2, so that's just 20 minus 2, which is 18, so that's U3. So we found the first 3 terms. For part C, it says write down the value of the common difference. Again, easy to do because you could use any of these. So 12 minus 6 give you 6, or you could do 18 minus 12, that would also give you 6. So the common difference is 6. Even if you got to part C and you notice, oh, I'm always subtracting these two, so they should have the same sign, then it should give you a signal for part A that, oh, I could use this fact to solve these questions. So for part D, calculate the 25th term of the sequence. So now we have the first term. And we have the common difference, so we can use the formula whenever they want the term, so you can use the formula. So I'm gonna go U25 is U1, which is 6, plus we want the 25th term, so we want the 25th term, so we're gonna go 25 minus 1 times the common difference, which is 6. And then we're going to simplify, so we get 6, and then 25 minus 1 would give you 24, so 24 times 6 would be 144, and then that plus 6 would just give you 150. So the 25th term is 150. For the last part, find the sum of the first 25 terms of the sequence, which means now that we have U1, U2 up until U25, we want to add all of these numbers. The long and really silly method is to actually find all the numbers and add them together. But you would obviously have to use the formula for the sum of the first n terms of an arithmetic sequence. So I'm going to use both formulas, but obviously one is easier than the other. So for the sum of the 25 terms of the sequence, let me just write the full formula down. So you have the two formulas, S, N. So if you're adding the first 25, so it's going to be 25. It's going to be N, so in our case it would be 25 divided by 2. 2 times the first term plus n minus 1 times the common difference. I like to put loads of brackets. And then you have the other form, which comes from here, so they're exactly the same. N over 2, U1 plus UN. Which means that if you know the last term you're meant to be adding, in this case it's the U25, which we found to be 150, then you can just plug it in here and it's much easier to use. So in our case, it's much easier to use the second formula than the first formula. I'm going to start with the second one and then use the first to check my answer. So S25 would be 25 divided by 2. U1 in our case is 6, so I'm going to go 6. And this in our example is U25 because we've done as 25, we put 25, so you're basically, again, matching the ends together. So we have U25 to be 150. You'll notice that a lot of the questions would ask you to find the term, and then they'd ask you to find the sum of the term. So we add the numbers together, we're going to get 156 in the bracket, and then we get 12.5 times 156, and the answer is 1950. You should get a whole number because you're adding whole numbers in here, unless you're adding decimals. Let's check our answer using the other long method. You use the other formula in case you don't have the last term, because what you're doing here is basically finding the last term again, in case you don't have it. So we have 25 over 2 again. This time is 2 times 6. So we go 2 times the first term, n minus 1 d. So our n is 25 minus 1 times the common difference, which we found to be 6. And then we're going to simplify this. You could do it all at once or step by step. I prefer to do it step by step when I'm explaining. So you get 12 plus 144. And so you should get the same answer. So 12 plus 144 is going to be 156. And again, we're back in this situation. And you'd get 1950. And that's it. That's how you solve the question. This basically covers everything we've done. I mainly wanted to give you a hint on the trick here on how to show that a value is such.